Hey everybody. In class today we talked about writing equivalent fractions using multiplication and division. Tonight we're going to talk about how to use that to be able to add and subtract fractions. So when we're adding and subtracting fractions that already have common denominators, there's just a couple of steps we have to do. Now the nice thing is that when we have fractions with common denominators, it means that the whole has been split into pieces that are the same size. And when they're the same size, it's a lot easier to compare them and add them together. For instance, if you look over here at this example on the right, we have 1/5, we have a whole split into 5 parts, and one of them is shaded in. And we have a whole split into 5 parts, and 2 of them are shaded in. So now we're looking at how many fifths do we have altogether. We have 1, 2, 3 fifths, so we have 3 over 5 as our answer. 1/5 plus 2 fifths is 3 fifths. So when we add fractions with the same denominator, the denominator of the answer stays the same, right? 5 is the same as the denominators in the problem, because the size of the pieces don't change when we add them together. So all we have to do is add the numerators, leave the denominator the same. So let's try that in our first two examples. In example A, we have 1/10 plus 7/10. So we know our denominator is going to be 10. Right? The size of the pieces don't change. And in our first fraction, we have 1 piece that size. In our second fraction, we have 7 pieces that size. We put those all together, gives us 8 pieces, 8/10. Now, we have a problem here because our fraction can be simplified. I notice these are both even numbers. So I can divide 8 by 2, and I can divide 10 by 2. 8 divided by 2 is 4. And 10 divided by 2 is 5. So there's my answer. 1/10 plus 7/10 equals 4 fifths. In our second example, we have 7/12 minus 3/12. Subtraction is the same. Our denominator stays the same, and we subtract the numerator. 7 minus 3 is 4. And in this case, I notice I can simplify this again. I can divide the top and the bottom by 4. 4 divided by 4 is 1. And 12 divided by 4 is 3. So if we do 7/12 minus 3/12, we actually get 1/3 as our answer. When we have unlike denominators, when fractions have different denominators, like 2 fifths and 1/2, addition and subtraction gets a little bit harder. It's tough to know how much total we have when we have 1 piece over here that's this size and 2 pieces over here that are this size. We can't really say, well, we have this many pieces of this one size. So in order to fix that, we have to rewrite the fraction so that we have all of the pieces of the same size. So we have the same denominator, or a common denominator. In order to do that, we can do it the same way we found equivalent fractions in class today. We just have to multiply the numerator and denominator by the same number. So I know that 5 and 2 both go into 10. So I can multiply 5 times 2. And 2 times 2, because that'll give me 10 in the denominator here, and it will give me 4 in the numerator. 1/2, I know 2 goes into 10. I know 2 times 5 equals 10. So I have to do 1 times 5, which will give me 5. So I have 4/10 plus 5/10 now, and now this is just like the problems we just did. I have 9/10 as my answer. And we can see over here in our diagram, I have 4/10 in this, and I have 5/10 over here, so that gives me 9 pieces that are all the same size, 9/10. Let's wrap up with 2 more examples where we add numbers with unlike denominators. So in our first example, 1/6 plus 2/9, we have to find a number that 6 and 9 both go into. It can be really useful to have a multiplication table handy so we can look at the multiples of 6 and 9 together. Remember, you always have that in the back of your blue book. So 6 and 9, I know both go into 18. So I can multiply 6 times 3, and I can multiply 1 times 3. 1 times 3 is 3, and 6 times 3 is 18. And then I can do 9 times 2 to get 18. So that gives me 18 in my second denominator, and I can do 2 times 2, which is 4. Now when I add those together, I know my denominator is going to be 18, I know my numerator is going to be 7. And I have my answer. I can't simplify that. 7's a prime number. I know 7 doesn't go into 18, so that's my final answer. In example D here, we have 10 and 4. So we have to find the common denominator there. Again, multiplication table really useful here. So I know 10 and 4 both go into 20. So I know my denominators are going to be 20. I can write that right now. Now 10 times 2 is how I get 20 for the first fraction. So I have to do 9 times 2, which gives me 18. So I have 18 over 20. And then I have 4. I know 4 times 5 is 20. So I have to do 3 times 5, which will give me 15. 18 minus 15 gives me 3. So 3 over 20 is my final answer. And again, I can't simplify that. So those are all of our examples tonight. Go ahead, finish your questions and summary, and don't forget to submit it through Canvas. I'll see you all in class tomorrow.